So I just wanted to do a really quick video on magnification, okay, and magnification calculations. So a lot of people tend to get confused with this, and they tend to get confused with the whole process of the calculations. I think that's mainly because students don't tend to understand how things are scaled. So to begin with, let's talk about 1 centimetre is equal to 10 millimetres. Okay, so for every centimetre, you have 10 millimetres in that centimetre. Now, in biology, we don't work with millimetres really, because just to put into perspective, an ant is about 3 millimetres in length, but the ant is made up of thousands, if not millions of cells. So cells are absolutely tiny. An animal cell is typically about 50 micrometers, and that's a large cell. A red blood cell would have a diameter of about 7 micrometers. But what's a micrometer? So 1 millimeter has 1,000 micrometers in it. Okay, so 1 millimeter has 1,000 micrometers in it. Therefore, to convert millimeters into micrometers, and that's what this symbol is, it stands for micrometers, you would times your millimeters by 1,000. However, to convert micrometers back into millimeters, you would need to divide by 1,000. Okay, so you're always working in magnitudes of 1,000. We don't always work with micrometers. When we're looking at things like organelles, we often have to work with an even smaller increment, and this increment is known as a nanometer. So 1 micrometer has 1,000 nanometers in it. Okay, so 1 micrometer has 1,000 nanometers in it. Therefore, to convert micrometers into nanometers, you would times it by 1,000. And again, on the flip side, to convert nanometers back into micrometers, you would divide by 1,000. Okay? But how do we convert nanometers and micrometers apart? Well, 1 millimeter, so 1 millimeter has 1,000,000 nanometers in it. So 1, 2, 3, 4, 5, 6 nanometers. Okay? So 1 millimeter has 1,000 micrometers in it. 1 micrometer has 1,000 nanometers in it. Therefore, 1 millimeter has 1,000,000 nanometers in it. So we can say, therefore, that's what these 3 dots mean, by the way. It means therefore. We could say that to convert nanometers into millimeters, we would divide by 1,000, or divide by 1,000,000 even, sorry. Whereas to convert millimeters into nanometers, we would times by 1,000,000. Okay? So before you move on in this video, make sure you've got these figures as reference somewhere, because you're going to need to be able to freely convert millimeters into micrometers, micrometers into nanometers, and vice versa. A lot of students lose silly little marks in calculations because they don't convert everything into the same units. So you'll see in some exam questions that I'll give you in a moment that you need to convert things into the same units, otherwise your answer will be incorrect. So make sure you've got this written down somewhere. While you're writing that down, let's just get a simple definition out of the way, and it's in green, so it's a definition. Magnification is defined as how many times bigger an image looks under a microscope. So, how many times bigger an image looks under a microscope. Now you'll always see that magnification is like usually numbers of, say, times 100 or times 1000. Now all this means is that the image is 100 times bigger than the real thing, whereas this one will mean that it's 1000 times bigger than the real thing, the image under the microscope. So if you haven't already, pause the video and make sure you've got these numbers written down for your reference. Okay, so you should have got that written down. We now need to have a quick look at how we do the calculations for magnification. Now, I like to do this in an image because, in a triangle, sorry. The reason I like to do this in a triangle is because my maths is not the strongest. So if we put this in a triangle, we would have the size of the image at the top. So this would be the image you see on the screen or on the piece of paper. So that would be the top of our triangle. Down the bottom left, we would have the magnification. And then in this bottom right hand box, we would have the real object size. Now, to use these sort of triangles, which I love in maths, especially at GCSE science, you simply look at the one you want, put your thumb over it, and then calculate the rest. So for example, if I was to take the red and I wanted the magnification, I would put my thumb over that, and it tells me that I want the size of the image divided by the real object size. Whereas if I wanted to find the size of the image, I would put my thumb over the size of the image, and that tells me I need to do the magnification times the real object size. Or if I wanted to find the real object size, I will put my thumb over that, and it tells me I need to do the size of the image divided by the magnification. So just to clarify, sideways on these means times. When it's above and below, it means divide, like so. Okay? You are going to need these triangles as we work through, but I'm not going to write it out like this every time. All I'm going to do is I'm going to put I for the size of the image, M for the magnification, and R for the real object size. And you'll see me draw it each time we do an example, like so, in the top left-hand corner, just for our reference. Okay? So let's have a look at an example. If I draw our triangle as promised up here, we've got the image size, magnification, and the real object size. Put down a nice triangle. I would say neat, but it's not the neatest. Like so. And let's suppose that you get a following exam question. An object or a cell has a size of, let's say, 7 micrometers. Full stop. The image has a size of 7 centimeters. Calculate the magnification. Okay, so we've got a cell that has a size of 7 micrometers, but the image is 7 centimeters. You need to calculate the magnification. So if we cover our magnification, that tells us that we need to do the image size divided by the real size. So our image size in yellow is 7 centimeters, but our real size in green is 7 micrometers. Now the first problem we've got here is that their units are totally different, so we need to convert this 7 centimeters into micrometers. Now we said earlier, if you look back at the written down numbers that I gave you, you should have that 7 centimeters is equal to 70 millimeters. And to convert 70 millimeters into micrometers, we need to times it by 1,000. So 70 times 1,000 gives us 70,000 micrometers. Okay? So we've now got them in the same units. We've now got that the real size is 7 micrometers, whereas the image size is 70,000 micrometers. So all we would need to do now, quite simply, is we would need to do our image size, which we've changed into micrometers, 70,000, divided by the real, which is 7, to give us our magnification. So 70,000 divided by 7 gives us a magnification of 10,000. Now, because this is magnification, we always put a times in front of it. So it's saying that this image is 10,000 times bigger than the original. Okay? Now, you won't always be given the question like this. Okay? So if we get rid of this, we put our triangle back at the top. So we've got our image, our magnification, and our real size, like so. You may sometimes be given a picture, okay? And this picture will just be of some cells. So let's say that this is the image you're given, okay? And you're asked to find the real size of the cells. So we're going to look for the real size. So find the real size of a single cell if the magnification is 10,000. Okay? So we want this. We want the real size. So we can scribble this out. It tells us we need to do the image size divided by the magnification. Okay? So it wants a single cell. The question is saying a single cell, not the whole thing. So what I would do here is I would pick a cell, say this one. I would get a ruler and I would measure from there to there. Okay? So let's say, for argument's sake, that this is 2 centimeters. So we've measured 2 centimeters. Now, we said earlier that cells are not measured in centimeters. These cells are not 2 centimeters in size. So sometimes the examiner will ask for either micrometers or nanometers. In this case, we're going to ask for micrometers. So answer in micrometers. Okay? So we've said that this is 2 centimeters. 2 centimeters is equal to 20 millimeters. And then to convert that into micrometers, we would need to do times 1,000. So 20 times 1,000 gives us 20,000 micrometers. Okay? So our image size is 20,000 micrometers, because this is 2 centimeters. 2 centimeters is 20 millimeters. 20 millimeters is 20,000 micrometers. We would simply put that then into our calculation. So if I just get a couple of colours so I can show you where I'm getting these numbers from. Our image size is 20,000 micrometers, whereas our magnification is 10,000. You've been given that in the question. So if we work that out now, we would do 20,000 divided by, because we've put our thumb over the real image, 10,000, which gives us a real cell size of 2 micrometers. Okay, that would be our real cell size. Okay, another one which we can do, so if we go to new, don't save, and we put our triangle back here, image size, magnification, and real cell size, like so. We put our triangle together, and we add another image. This time we're going to add an animal cell. You may be given a different type of question where you're given something called a scale bar. Okay, so you could be given a bar on the page, like something like this underneath the question, that has a bar in the middle and it says 10 micrometers. This could be any number. Okay, what this is saying is that this distance on the image represents 10 micrometers. Okay, what I would do is I would measure this first, and you may measure that this is 1 centimeter from here to here. So every 1 centimeter on this image represents 10 micrometers. Okay, if you then measured this cell from here to here, you may find that it is 5 centimeters in width. If it is 5 centimeters in width, this image therefore represents 50 micrometers. Okay, so you know that the real size of this cell is 50 micrometers. Now, you may be asked to find the magnification. Okay, so find the magnification of this image. So we want to do the image size divided by the real. So we've already concluded that the real size of this is 50 micrometers. Okay, because 1 centimeter is 10 micrometers, it's 5 centimeters in width, therefore 50 micrometers. We now need to work out our image size in micrometers, because we can't work with 1 centimeters, the others in micrometers. So what we would do, 5 centimeters is the equivalent of 50 millimeters. To convert that into micrometers, we would do 50 times 1000 to give us 50,000 micrometers. Okay, now to find out our magnification, we need to do the image size, which we've just worked out is 50,000, divided by the real size, which we worked out from our scale bar is 50. So you would do 50,000 divided by 50 to give us, remember these are both in micrometers, they need to be the same units. So 50,000 divided by 50 will give us a magnification of 1000. So remember, this is magnification, so we would say that this image is 1000 times bigger than what it should be. Okay, so the final one we're going to do is working with a slightly different unit. So we can put our triangle back up here, image size, magnification, real size, like so. And this time we're going to look at an organelle. We're going to look at a mitochondria. So the mitochondria, remember, is a part of a cell where respiration takes place, but it's obviously, therefore, a lot smaller than a cell, an entire cell. Again, you may be given a magnification bar, like so, or a scale bar, sorry, and you may be told that each one of these represents 20 nanometers, okay? You're going to be asked to find the magnification again, so find the magnification. So you're going to need to measure this once more. So let's say that this time it is 2 centimeters in width. You measure from here to here, and you find that this is 6 centimeters. Therefore, you can conclude that the real size of this is 20 times 3, 60 nanometers. The width of this is 60 nanometers. Okay? Because we've got 6 centimeters, each 2 centimeters is worth 20 nanometers, so 60 nanometers. You now need to work out your real image size using this measurement. So you've measured that this is 6 centimeters. That is equal to 60 millimeters. To convert that into nanometers, you would do 60 times a million. Okay, to give you 60 million. So that is our that is our image size. So our image size we've just calculated is 60 million, whereas our real image size we calculated earlier was 60 nanometers. Just to clarify, these are all nanometers. So what we would do is we would do our image size, which is 60 million, divided by our real size, which is 60. These are both in nanometers. That's what we've converted them to give us 1 million, I think it is. To give us a magnification of 1 million. And this would be times 1 million. So this image is 1 million times bigger than what the real mitochondria would be. And that's it. Just make sure when you're working out magnification, real size, image, you use this triangle. You scribble out the one you're trying to work out. That tells you what you're left to do. So the image size divided by the real size. If you're given a scale bar, you know that this distance equals 20 nanometers on this image. Measure the size of your image. If it's 6 here, every 2 is worth 20 nanometers, so we know that this is 60 nanometers. Yeah? Convert your centimeters, your millimeters into whatever units being used. So if they give the scale bar in nanometers, you work it out in nanometers. If they tell you micrometers, you work it out in micrometers. And just follow the steps in order to get what's left. I hope this has been useful.